Great.
Once again, I'm Mr. Rabar, Review Director of Rabar Review Center, Philippines. Now, this video is a continuation of what we have discussed in analytical or analytic geometry. We have already discussed equation of lines, equation of a circle, equation of a parabola. Now, this time, I will show you how to find the equation of an ellipse, elliptical chord, or elliptical figure. Now, remember an ellipse has two positions. Could be an ellipse could be in horizontal elongation. Or it can be a vertical elongation of the chord. Wherein this can be considered as points of the vertices. Then remember, for the ellipse, we have two axes here. We have here the major axis and the minor axis in this form. We have also an ellipse like this, wherein the longest axis is along y. So we can have this as our major axis. Y, and this one is our minor axis along x. As to which one is longer, so from the center to the vertex here, we can consider it as A. Or from here to there is also A. And for the minor, here to the center we have B, or from here to here again is another B. Now, where A is what we call the semi-major axis. It is the length of the semi-major axis. It is semi because it is the distance from the center of the ellipse to the other side of the vertex. And B, which is the shorter one, the shorter axis, is considered as semi-minor axis. Here, in the second diagram, our vertices is along y, such that along y is our A, and along x is our B, from the center. So, the important aspects that can be considered in defining or in finding the equation of an ellipse are this semi-major and semi-minor axis, as to what is the value of this and the value of that. And also the points of the chord, and most importantly, the location of the center. Because the location of the center is supposed to be our coordinates x and t coordinate. Equation of an ellipse in this form, wherein our x is supposed to be the longest part, or wherein the major axis is along x. So we can have here x minus x squared over e squared, then plus y minus p squared over b squared is equal to 1. This is the standard form or the standard form of an ellipse. That is an ellipse wherein the major axis is along x-axis. But when the major axis is along y, so we can have here y minus p squared over a squared, where a is the longer axis. Then plus x minus 8 squared over b squared is equal to 1. These two will mean the same thing for an ellipse equation, but it depends upon the location of the major and the minor axis. If the major axis is along x, we can have this as an equation of an ellipse standard form. If the major axis is along y, we can have this as the standard form of the ellipse. Remember, a is the longer axis. That's why if it is in the vertical form, the longer axis is in y. That's why we have y to be paired with a. Now let us have an example or assumption, assuming that, by the way, the ellipse is defined. There is also a foci or a focus here, another focus here of an ellipse. The focus is the distance from the vertex to this point, and as well as this, that is the same distance as that, because this point is our focus point. Focus 1, focus point 2. Now, ellipse has a property wherein, a special property wherein the distance, the sum of the distance from the focus to any point of the chord to distance from the other side of the focus or another focus to that point also, the sum of the distance is equal to twice a. So, meaning, if I will call this as P, if I will just call this as Q, so F1Q, distance F1Q, then plus F2Q, distance F2Q, must be equal to 2 times A, or 2A, must be equal to twice this length, or the length of the major axis. So that is the property of an ellipse. As to whatever point to be considered here, then that one, if you add these two, will give you this distance here. Remember, this distance here to that point is 2A, because this one to center is A. Now, assuming that our B is, or our A is supposed to be 6, and B is, let us say, 3 units, but this must be positive, negative. A must be positive, negative. Positive, negative 3, because we are dealing with square. A squared means square root or positive, negative. So, if we consider A as positive 6 to the right, and positive to the left, and negative to the left, then B positive 3 to the upward and negative 3 downward. But be sure to know the center. The center of the ellipse, let us say the center of the ellipse is, let us say it is 1 for x, then p is 2. Positive 1x, positive 2 for y. Meaning it is just in this form. positive 1 and positive 2. So the location of the center of the ellipse is at this point. That is the center. But we have positive 6 there, then negative 6 there. So positive 6, so we have to add 7, 1, then 6 more, 2, 3, 4, 5, and 6. So therefore, this is the line where the vertex on the right is located. Then we have also negative 6 on the left side. We have 1, then 2, 3, 4, 5, and 6. So this is where our another vertex of the ellipse, but this is the center. Now the B is plus and minus 3. B is plus and minus 3. So we have a plus to the upward. From here, from the center, we have 1, 2, 3. So this is 3, positive 3. Then we have also negative 3. From the center, we have here 1, 2, 3, negatively downward. So therefore, if you're going to have that line or this line, so meaning this center is having this as the point where the intersection of this line of the focus, or this line of the center line, and the curve of the ellipse. This one also, the center, if you're going to extend the straight line here, the horizontal, it will have this point and that point as the left and the right vertex. Wherein we have here our A, the longer or the major axis, then we have also the minor axis here. So if you are going to trace this ellipse is something like this as the figure. So this ellipse has an equation using this data, has an equation of we have there this one as for this form, we have our x for the equation x minus x. Our x is supposed to be the x coordinate of the center. We have our 1, then square, and over a squared. Our a is supposed to be 6. So therefore, this is 6 squared or 36. 6 squared. Then this is plus y minus p. P is the coordinate of the center, 2. Then squaring this, then we have over the square of the y coordinate of the center, that is the y coordinate of the center is supposed to be located at y equals to 2. Okay, so this is 2 squared, then equals 1. Or this is x minus 1 squared over 36 plus y minus 2 squared over 4 is equal to 1. We can consider this as our standard form of equation of an ellipse, but we can still simplify this by expanding